In section 2.8, we're going to cover different types of variation problems. There's really going to be two main types of variation problems, and the first one that we're going to look at is called direct variation. By definition, we have direct variation is defined as a situation described by the following equation, which is y equals kx. The k in this equation stands for a constant, and it's the constant of variation, or it could be called the constant of proportionality. But no matter what, that's going to be constant. Now, the way this reads is y varies directly as x. So anytime you have a application problem or a problem and you see some of these main words like varies directly or is directly proportional, we know that we're going to be using direct variation. So if you see those key words, we're going to be using this equation, or if you want to look at it as a formula, y equals k times x. K is the constant, and that is y varies directly as x. So we multiply. So an example of direct variation, what it means to vary directly is if they're a direct relationship, if one goes up, the other one goes up, or vice versa. If one goes down, the other one goes down. So they have a direct relationship. Whatever y does, x is going to do it at a rate of that constant. So if the constant is 6, then that's the constant that the y and x varies and how they are proportional. Problems that involve direct variation, or just really any variation problems in general, are going to follow this certain procedure. And there's really going to be 4 steps that we take. These are actually kind of 2-step problems. And the first thing is these are going to be more of word type problems or applications, and the first thing we need to do is interpret that and write an equation. So if we see the words varies directly, or if we see one of the other keywords for some of the other variation that we're going to get to, then we pull the formula out based on what that equation is modeling, or what the word is modeling, and we're going to write that equation. So for instance, taking that, step 1, looking at example 1, we see y varies directly, so based on what step 1 is saying is I would write the equation for direct variation, which is y equals k times x. So we'll kind of go through these steps while we work this problem. So we have step 1. We looked for the keywords. It says varies directly, and since it's y varies as x, we're using the formula y equals kx. Now, keep in mind that y and x are just generic variables. This could say a varies directly as b. If it said a varies directly as b, then we would write that as a equals kb. Or if it said m varies directly as n, we would use m equals k times n. So you just kind of follow suit with what variables are given to you. But just generically, we define variation as x and y. But just make a note that it could be any variable. So y varies directly as x, that's our first step. We wrote the equation from step 1 up here that models what they gave me. Now step 2 says substitute the given pair of values into the equation. So if you read, that's step 1 goes with sentence 1. So we've got that done. Now they start giving me values here for what x and y are equal to. So I'm going to do what step 2 says, which is plug those in. So they tell me y is 45, so I'm going to replace my y with 45. They tell me that the x is 5. So when I plug this in, what we really have is 45 equals 5k. If I just kind of rearrange that, again, remember, k is your constant. They give me x and y. The only thing left to do now is let's figure out what k is. And that's the second half of step 2 up there, is once you plug everything in, find what k is equal to. So of course we know that we would finish this out by solving, divide both sides by 5, which gives my k by itself, and of course k is equal to 9. Okay, so that's, again, that was the second sentence of this little word problem. So that was step number 2. So now that we know what k is, we go back up here and read step 3. It says now substitute the value of k back into your original equation. So since my original equation is y equals k times x, and I now know that k, no matter what happens to x and y, I now know that k is 9 no matter what happens to x and y. So no matter what, my k is going to be 9. So now I know, or now I have a way to finish out the problem. So step 3 is done. Now that we know k, that k is always going to be 9. And it allows me to solve the last step of this problem, which says, okay, well now let's say that x goes from 5 to 13. So x is going up from 5 to 13. Now let's find out what y is going to be. So find y. Now, if x is 13, so I'm going to plug in x for 13. And when we do our multiplication here, we end up with 117. Okay, so one way we can kind of get a check on ourselves is, and this is the final answer, this is what we're trying to get to. And it takes 2 steps to get there. X went from 5 to 13, so it went up. So since they vary directly, we would expect that y also went up, and it did. It went up from 45 to 117. Okay, so that's just what we're looking for in these problems, is we're going to pay attention to the key words and then apply that to the equation. Okay, the other type of variation that we're going to look at is inverse variation. And all of our variation problems are going to fall into one of these 2 categories. Now, there's different versions of direct variation, which we'll look at, but it's either going to be k times x or k divided by x, which is inverse variation. And if you see some of the keywords like varies inversely or inversely proportional, then we know that we're going to be using this formula. Inverse variation, unlike direct variation, where direct, if one goes up, the other one goes up, they were doing the same thing. Inverse means they're doing the opposite. If y is going up, x is going down. If x is going up, then y is going down. They have an inverse relationship. Okay? Again, the only difference here is instead of k times x for direct, this is k divided by x. The k is still our constant of variation or constant of proportionality. So example 2 models this. Again, we're going to use the same 4 steps that we used in the first example, and we're going to start with step 1, which goes with sentence 1 of our word problem. It says y varies inversely as x. So, since it says varies inversely, instead of k times x, that's going to be k divided by x. Now they give me numbers to plug in. Now they're telling me y is 12 and x is 5. So we do know that to solve this problem here, I've got to get the k by itself. The opposite of dividing by 5 is multiplying by 5. Whatever we do on the left, we have to do on the right. So the 5's cancel, which give me my k by itself. And this time my k is equal to 60. So now that I know that, no matter what, that k is going to be 60. It doesn't matter if x and y change, k will always be 60. So we have y equals 60 over x. And that was sentence 2. Got that taken care of, which was step 2. Step 3, we plugged it back in, plugged the k back in. And now we're ready to finish this problem out, which says, now find y if x is 2. So we plug in for 2, and we just have to do the math, which gives me an answer of 30. And that's my final answer. What happened to the y if my x changed? Okay? Now again, with inverse variation, you kind of check yourself here. X was 5, and x went down. So if x went down, y should have went up, and it went from 12 to 30. So it did have an inverse relationship. If one goes down, the other one will be going up. Okay, so again, everything kind of falls into these 2 categories of either direct variation or inverse variation. And then we have some different kind of just versions of what happens. You know, we can kind of add to direct variation, and we can add to inverse variation a little bit. But there's going to be 2 that we're going to kind of look at that still fall under the category of direct variation. And the first one is direct variation with powers. And this just means that y still varies directly. So it's still going to be multiplication, k times x. But this is just saying, well, what if your x is not just an x? What if it has a power, if it has an exponent attached to it? So if it did, instead of just y equals kx, if my x is to some power, it may read something like y varies directly as the 5th power of x. Okay, so that would be to the 5th power. It may say y varies directly as the square of x, which means we would put an exponent of 2 since that's squared. we could read things as y varies directly as x, or it could say y varies directly as the cube of x, which would be to the third power. So that's all we're saying there, but it still varies directly. It's still direct variation. So again, just pay attention to your x. Pay attention to how it's varying directly. Does it have an exponent attached to it? Okay. And before we work example 3, let me skip down and show you another type of variation, which still involves direct variation, and it's called joint variation. Joint variation is a variation in which a variable varies directly. So again, it still falls under the category of direct variation, but instead of just y and x, it may have another variable that it's also proportional with. So it could be y varies directly as x and z. But instead of it saying x or y varies directly, this is more of how it's going to read. It will actually use the word jointly. If you think about jointly, if you think about joint and joining things together, it just means you have more than one. So instead of just y being related to just the one x, it's now joined with another variable. Okay, but it's still direct variation. It may read varies directly, or it may read varies jointly. Most likely it's going to read, when you see these in the problem, varies jointly. So you'll need to be able to recognize that that is just direct variation. There's just more than one. Okay, you're joining more together. So instead of just y equals kx, it'll be y equals kx, and then you'll have your third, or technically your second variable over there with your x. Okay, so all of those four different types of variation all fall either under the category of direct variation or inverse variation. So let's go up here and do example 3. It says just write an equation. We're not going to solve anything. We're not going to plug anything in. This is just practice using the formulas, because the biggest thing about these problems is if you can't get the problem set up correctly, then when you go to start plugging the numbers in, they're all going to be wrong anyways. So for example 3, starting with the same 4 steps, is step 1 is you got to set it up. And we're looking for keywords of how it varies. Now, x varies jointly. Jointly is still direct variation. It's still going to be multiplication. Now, pay attention, they've swapped the variables on me. Instead of y varies jointly as x, they have x varies jointly. So instead of y equals, it's going to be x varies jointly as y and square of z. So I'm going to square the z. So it's pretty much at face value. It's kind of point blank out there. You just have to be able to interpret it. Okay, there's nothing really hidden. They're giving you x, they're telling you how it varies, and then what variable it varies as. Don't forget that this k is going to be in every single one of these problems. K is just part of your the variation part. It's your constant. Okay, so again, not working that one out, just going to set that one up. And then we can expand that to example 4, where we're going to set it up, and then we will go through and actually solve this. So we have c varies jointly as a and t. And then they tell me what to start plugging in. But again, this is what it all kind of evolves around, is your first sentence, because you got to get it set up correctly. Again, I'm looking for my keywords. Varies jointly, which means it's a direct variation. So we have c varies jointly as a and t. So k times a times t. So we have it set up. Varies jointly means I'm still doing direct variation, which means I'm still going to multiply. I got my k in here because the k has to be here. And it's jointly as a and t. Now, step 2. They tell me what to plug in for my numbers. They give me c is 175. They don't start out giving you your k. That's what we're going to solve for. They tell me that a is 2100. They tell me t is 4. And now all I have to do here is solve for k. So simplifying this out, I get 175 equals 2100 times 4 gives me 8400 times k. dividing both sides by 8400 so that I can get my k by itself. Of course, that cancels out, giving me my k by itself. You can do this a couple different ways. If you actually divide that, you will get a long decimal. So let me show you what that looks like when we actually divide that. Now, some of them, if they give you a terminating decimal, it's okay to use as a decimal. But if I try to do 175 divided by 8400, we're going to get a decimal of 0.0208, and then the 3 repeats. If you have a repeating decimal, you have to round that, and then you're going to end up with an answer that's going to be off just slightly. So if it doesn't divide evenly or divide into a terminating decimal, what I mean by terminating decimal is if you had 1 over 4, that terminates. It's 0.25. There's nothing to round. That's the exact decimal that it's equal to. Or if you had 1/2, we know that's 0.5. If you get something like this, then don't put it as a decimal and don't round it. What I suggest you do is just reduce the fraction. And 175 over 8400, both of those are actually divisible by 175, excuse me, not 75, but 175, which will actually give you 1 over 48 when you reduce that. Okay, so even if you kind of start reducing it down by 5 and then looking at it again and then reducing it again until you get down to that, that's okay. But get it fully reduced. So now we're going to take the 148 or 1 over 48 and we're going to replace it into the original equation. So the k we know is going to be 1 over 48 times a times t. So that's how it's going to vary. And now they give me the last part, which say, okay, now that you know what k is, let's see what happens to c if a moves up to 2400 and t moves up to 6. Again, what you get here is if you multiply straight across, just rules of fractions, you get 14,400 in the numerator over 48. And when you do that division, it does divide evenly into 300. So that is your final answer. That's what C is equal to. Okay, now, again, since this was direct variation, A went up, T went up, and my answer for C also went up. Okay, so it kind of all checks out. Alright, so keep in mind that everything is going to depend upon how you get the problem set up and how you interpret the original problem. The rest of it's just going to be evaluating, plugging in the numbers that they give you, and then of course solving the equation, which is usually just going to be one step to get it solved. So make sure you pay attention to the wording. Look for varies directly, which is multiplication, varies directly with powers, varies jointly. All of those are just going to be multiplication, and don't forget to put in your K.